In an era increasingly defined by our collective consciousness of environmental impact and the urgent need for sustainable practices, the quest for natural, effective solutions has never been more critical. Across the vast tapestry of global agriculture, a silent revolution is underway, driven by a return to nature's wisdom, amplified by modern scientific prowess. At the heart of this movement lies a remarkable botanical marvel, the neem tree. For millennia, indigenous communities across the Indian subcontinent and beyond have revered this tree, often calling it Sarva Roga Nivarini, the curer of all ailments, or Arishta, meaning reliever of sickness. Its leaves, bark, seeds, and oil have been integral to traditional medicine, pest control, and even cosmetics. Today, we embark on an extraordinary journey, stepping inside a state-of-the-art American factory where this ancient wisdom is meticulously combined with cutting-edge innovation. Here, the humble neem leaf, a repository of nature's potent defenses, is transformed into a sophisticated organic pesticide, a cornerstone of sustainable farming for the 21st century. This is the intricate story of how nature's profound power is harnessed, refined, and delivered, cultivating a healthier future for our planet and its people. Our comprehensive journey begins long before the factory gates, amidst the vibrant sun-drenched fields where neem trees, Azadirachtin indica, flourish. The very foundation of a high-quality organic pesticide rests squarely on the quality of its raw material. Unlike many industrial processes that rely on synthetic inputs, this endeavor starts with life itself, the living, breathing neem tree. These trees are often cultivated on sustainable farms, frequently in tropical and subtropical regions where the climate is ideal for their growth. These farms are not merely plantations, they are ecosystems in themselves, prioritizing ecological balance, biodiversity, and responsible land stewardship. The meticulous process of harvesting neem leaves is a critical first step. It's a delicate dance between efficiency and preservation. While some larger operations might utilize specialized mechanical harvesters designed to minimize stress on the trees and damage to the leaves, many sustainable farms still rely on skilled workers who carefully hand-pick the vibrant green foliage. This manual approach ensures that only the healthiest, most potent leaves are selected, free of disease or significant damage. Close-up shots reveal the intricate venation of the fresh, vibrant green neem leaves glistening under the sun, each one a tiny factory of natural compounds. Once harvested, the leaves are not simply tossed into any container. They're collected into large, breathable sacks or specially designed containers that allow for air circulation, preventing premature degradation or the buildup of moisture that could lead to mold. This careful handling is crucial because the active compounds within the leaves, particularly azadirachtin, are sensitive to environmental factors. The journey from the field to the factory must be swift and efficient, often involving refrigerated transport to maintain optimal conditions. Upon arrival at the factory's receiving bay, a bustling hub of activity, the raw material undergoes a rigorous and multi-layered inspection. Factory personnel, often equipped with specialized training, meticulously examine the incoming neem leaves. They check for quality, freshness, and crucially, the absence of contaminants such as mold, pests, or foreign matter. This initial quality control is paramount. It's the first line of defense, ensuring that only the purest and most potent raw material enters the production stream. Each batch is weighed, documented, and assigned a unique identifier, establishing a chain of custody that allows for complete traceability from the field to the final product. This meticulous record-keeping is not just good practice, it's a cornerstone of organic certification and quality assurance. Once cleared by the stringent initial inspection, the leaves transition into the pre-processing stage, a critical phase meticulously designed to prepare them for the subsequent extraction. This stage encompasses two primary steps: thorough cleaning and careful drying. Both are executed with precision to remove impurities and reduce moisture content without,
crucially, degrading the valuable active compounds within the leaves. The leaves are first fed onto a conveyor belt, gently moving towards an automated washing station. Here, they undergo a sophisticated cleaning process, often utilizing filtered, purified water. Gentle jets or rotating brushes carefully remove any residual dirt, dust, or environmental debris that might have adhered to the leaves during harvesting and transport. This isn't a harsh wash, it's a delicate cleansing, ensuring the integrity of the leaf structure and its precious contents. Following this thorough rinse, the leaves move through a rinsing stage, removing any lingering impurities. The next step, drying, is perhaps even more critical. The leaves enter large, controlled drying chambers. These are not simple ovens. They are advanced systems, often employing low-heat convection dryers, vacuum dryers, or even freeze-drying technologies, depending on the specific factory's protocols and desired outcome. The goal is to reduce the moisture content significantly, inhibiting microbial growth and concentrating the active compounds, but without subjecting the leaves to temperatures that would degrade azadirachtin and other beneficial limenoids. Azadirachtin, the primary active compound, is known to be thermolabile, meaning it breaks down under high heat. Therefore, the drying process is slow, deliberate, and precisely controlled. Monitoring equipment constantly displays temperature and humidity levels within the chambers, ensuring optimal conditions are maintained. Technicians regularly check the moisture content of the drying leaves, often using specialized sensors, to ensure they reach a specific, low moisture level, typically below 10%, which is ideal for subsequent processing and long-term stability. Close-up shots reveal the transformation, vibrant green leaves gradually becoming crisp, their color deepening slightly, their texture changing as moisture is gently coaxed out. This careful drying process is a testament to the scientific understanding applied to ancient wisdom, ensuring the maximum preservation of the neem's natural power. With the leaves meticulously cleaned and perfectly dried, the next step in this intricate industrial ballet is their transformation into a fine powder. This process, known as grinding or milling, is far more than simple pulverization. It's a calculated step designed to dramatically increase the surface area of the neem material. Why is surface area so important? Because a greater surface area allows for significantly more efficient extraction of the active compounds in the subsequent stages. Precision grinding is absolutely key to achieving the desired particle size and consistency. The dried leaves are fed into industrial-grade grinders or hammer mills. These powerful machines are engineered to efficiently break down the leaf material, often using high-speed rotating hammers or blades, into a fine, consistent powder. The process is carefully controlled to prevent excessive heat generation, which, as we've learned, could compromise the thermolabile azadirachtin. As the leaves are milled, a fine, almost talc-like neem powder emerges. This powder doesn't just fall into a collection bin. It typically passes through a series of sophisticated screens or sieves. These screens are calibrated to specific mesh sizes, ensuring that only particles within a desired size range proceed. Any larger particles are often recirculated back into the mill for further grinding, guaranteeing uniformity. This meticulous control over particle size is crucial for optimizing the efficiency of the upcoming extraction process. Technicians regularly collect samples of the powder for quality checks, which often include particle size analysis using laser diffraction or other advanced techniques. This ensures that the powder meets the exact specifications required for maximum extraction yield. Once approved, the freshly ground neem powder is transferred to large, sealed containers or specialized silos. These storage units are designed to maintain controlled conditions, protecting the powder from moisture, light, and air, all of which could degrade its potency. This careful storage ensures that the precious raw material remains stable and ready for the most critical stage of the entire process: extraction. This is where the true magic of modern science unlocks nature's profound power, the extraction of azadirachtin and other beneficial limonoids. These are the complex organic compounds responsible for Neem's remarkable pesticidal and insecticidal properties. Modern factories employ highly sophisticated and often proprietary extraction methods, moving far beyond traditional, less efficient techniques. The primary goal is to isolate these active compounds efficiently, purely, and without degradation. The Neem powder, now perfectly prepared, is carefully loaded into large, gleaming stainless steel extraction vessels. These vessels are robust, designed to withstand precise control over temperature and pressure, depending on the chosen extraction method. One of the most advanced and environmentally friendly methods is supercritical fluid extraction, or SFE, often using carbon dioxide, CO2, as the solvent.
Confirmed.
CO2 is heated and pressurized beyond its critical point, transforming it into a supercritical fluid. In this state, CO2 exhibits properties of both a gas, allowing it to penetrate the Neem powder easily, and a liquid, allowing it to dissolve the active compounds. The supercritical CO2 selectively dissolves azadirachtin and other limonoids from the Neem powder, leaving behind unwanted plant material. The beauty of SFE is that once the extraction is complete, the pressure is simply reduced and the CO2 reverts to a gaseous state, leaving behind a pure, solvent-free Neem extract. The CO2 can then be captured and recycled, making it a highly sustainable process with minimal environmental impact. Another widely used and effective method is solvent extraction, often employing food-grade ethanol. Ethanol is a polar solvent that effectively dissolves azadirachtin and other active compounds. In this process, the Neem powder is steeped in ethanol under controlled conditions, allowing the active ingredients to leach into the solvent. After a specific duration, the solvent, now rich with Neem extract, is separated from the spent leaf material through filtration or centrifugation. The ethanol is then recovered through distillation and recycled, leaving behind a concentrated, crude Neem extract. This method is also highly efficient and, when using food-grade ethanol, ensures a safe and pure product. Regardless of the method, the process is meticulously monitored. Control panels display real-time data on pressure, temperature, and flow rates, ensuring optimal conditions are maintained throughout the extraction cycle. Technicians constantly monitor the process, taking in-process samples for analytical testing to ensure the extraction is proceeding as expected and achieving the desired yield. The crude extract, a dark, viscous liquid, is then carefully transferred to specialized storage tanks, awaiting the next crucial stage of refinement. This stage is a testament to how cutting-edge chemical engineering can unlock and concentrate the very essence of nature's defense mechanisms. The crude extract, while undeniably potent, is a complex mixture containing not only the desired azadirachtin and other limonoids but also various waxes, chlorophyll, and other plant compounds. To create a highly effective, stable, and pure organic pesticide, further refinement and purification are absolutely necessary. This stage is dedicated to concentrating the active ingredients to their optimal levels and meticulously removing any undesirable components that could affect product performance, stability, or safety. The crude Neem extract embarks on a series of sophisticated purification steps. These may include advanced filtration systems, such as membrane filtration, which uses semi-permeable membranes to separate components based on molecular size, or activated carbon filters, which absorb impurities and unwanted color compounds. Further concentration often involves distillation columns or evaporators. These systems gently remove residual solvents or water, effectively reducing the volume of the extract while simultaneously increasing the concentration of the active compounds. In some processes, centrifuges might be employed to separate different components of the extract based on their density. Throughout this entire refinement process, rigorous laboratory testing is not just an afterthought. It's an integral, continuous part of the operation. Analytical chemists, utilizing state-of-the-art equipment like high-performance liquid chromatography, HPLC, and gas chromatography mass spectrometry, GCs, meticulously analyze samples at various stages. HPLC is particularly crucial for precisely quantifying the concentration of azadirachtin, ensuring it meets stringent specifications. GCMS provides a detailed fingerprint of the extract, allowing chemists to identify and quantify other limenoids and verify the absence of any unwanted compounds. These sophisticated analytical techniques ensure the extract's purity, potency, and consistency. Close-up shots reveal the transformation, the crude, dark, viscous liquid gradually becoming a lighter-colored, clearer, and more concentrated form of purified neem extract. This refined extract, now a highly concentrated and potent solution, is transferred to specialized storage tanks, meticulously maintained under controlled conditions to preserve its efficacy, ready for the final, crucial step, formulation. A concentrated extract, no matter how potent or pure, isn't directly usable by farmers in its raw form. It needs to be carefully formulated into a stable, user-friendly product that can be easily applied in agricultural settings. This critical stage involves blending the purified neem extract with a precise combination of inert carriers, emulsifiers, and stabilizers to create a product that is both effective and practical for real-world application, whether as a liquid concentrate, a wettable powder, or a granular pesticide. The purified neem extract is carefully introduced into large, industrial-grade mixing tanks. Here, it is combined with a proprietary blend of other ingredients. Inert carriers, such as water or specific oils, provide the bulk of the product and ensure proper dilution. Emulsifiers are absolutely essential. Neem extract is oil-based, and without emulsifiers, it would not mix readily with water, making it impossible for farmers to dilute and spray effectively. These compounds allow the oil and water phases to blend seamlessly, creating a stable emulsion. Stabilizers are also crucial, as they help maintain the product's efficacy and shelf life over time, protecting the active compounds from degradation due to light, heat, or oxidation. Automated stirring mechanisms within the tanks ensure thorough and homogeneous blending, creating a consistent product from batch to batch. Throughout this formulation process, technicians meticulously monitor critical parameters. They check pH levels, ensuring the product remains within an optimal range for stability and plant compatibility. Viscosity is measured to ensure the product flows correctly and can be easily sprayed. Stability tests are conducted on small-scale lab samples, checking for phase separation or degradation under various conditions. This precise control over the formulation process is paramount. It ensures that the final product is not only effective but also stable, has a predictable shelf life, and is easy for the end user to apply. The result is a consistent, high-quality organic pesticide, ready to be transferred via pipes to the filling lines, poised for its final presentation to the world. This stage truly bridges the gap between raw botanical power and practical agricultural application. Before any product is allowed to leave the factory and reach the hands of farmers, it undergoes a final, comprehensive battery of quality control tests. This is not merely a formality, it is a critical safeguard, ensuring that every single bottle, jug, or bag meets the highest possible standards of purity, potency, and safety. Samples from each and every batch of the finished, formulated product are meticulously collected and subjected to a rigorous array of analytical and performance tests. These tests include, but are not limited to, verifying the precise concentration of azadirachtin, ensuring it matches the label claims. Chemists also check for any potential contaminants, including heavy metals or microbial growth, which would render the product unsafe or ineffective. pH levels are re-verified, as is specific gravity, to ensure consistency. Crucially, long-term stability tests are conducted, often involving accelerated aging protocols, to predict the product's shelf life and ensure its efficacy remains consistent over time. Certificates of analysis are generated for each approved batch, providing a detailed record of its quality. Only batches that successfully pass all these stringent evaluations are approved for packaging. The product then moves to highly automated packaging lines, a marvel of modern industrial efficiency. Bottles, jugs, or bags move along conveyors, precisely filled with the formulated pesticide by automated machinery. Capping machines swiftly and securely seal the containers, followed by sophisticated labeling machines that apply clear, durable labels containing essential information, usage instructions, safety precautions, batch numbers for traceability, and expiration dates. Some products may also undergo shrink wrapping or be placed into protective boxes. Finally, the finished products are grouped, stacked neatly onto pallets, and prepared for shipment. Warehouse scenes reveal neatly organized rows of pallets, each laden with boxes of organic neem pesticide, ready for distribution to farms, nurseries, and gardens across the nation and around the world. This final stage is the factory's promise to its customers, a commitment to delivering a product that is consistently effective, safe, and reliable. The journey we've witnessed, from a humble leaf plucked from a neem tree to a sophisticated, highly effective organic pesticide, is a profound testament to the power of innovation, scientific rigor, and an unwavering commitment to sustainability. Inside this modern U.S. factory, the process is far more than mere manufacturing. It is a meticulous alchemy, transforming nature's raw potential into a refined solution for contemporary agricultural challenges. By harnessing the inherent, natural defenses of the neem tree, these advanced facilities are not just producing a product, they are actively cultivating a healthier, more sustainable future for agriculture. They are playing a pivotal role in reducing the global reliance on synthetic chemical pesticides, which often carry significant environmental and health risks. The widespread adoption of organic neem pesticide supports a more balanced and resilient ecosystem. It promotes biodiversity by being non-toxic to beneficial insects like bees and ladybugs, and it safeguards soil health, a vital component of sustainable farming. This organic solution represents a powerful and essential step forward in our collective commitment to sustainable farming practices, demonstrating unequivocally that nature, when deeply understood, meticulously respected, and intelligently applied through modern science, offers the most profound, elegant, and enduring solutions for the challenges we face. It is a beacon of hope for a greener, healthier planet, where agriculture thrives in harmony with the natural world, ensuring food security and ecological integrity for generations to come.